Hi guys, I wanted to show a walkthrough of this beer scene. I have main dummy object here, point helper, and it's pointing in this direction, z direction, and I am using it with flow emitter to emit fluid. So this is like bottle's mouth, and it's brought up into tip TP using object to particle with object to particle, and we use its position to emit flow emitter particles. So I will just disable this flow group setup here, and we can see that it creates nice looking effect like this, and we need to turn on pouring for that. And yeah, I mean, if I increase looking here, it will be more, and with less it's less, and frequency for how fast how much frequent it should be. So I will use just default add here, and I am using raster to emit the fluid. So with raster method we get really nice distribution of fluid stream here, and of course a little bit of variation like 0.5 or 1.5 is nice. And I'm also using this x get value to flatten out the liquid a little bit here, and that I got using flow group settings. So while I was doing flow group settings, I figured doing some xget here, and of course I am using a little bit big radii size factor for these scales. So I wanted a thin stream of beer. So as I was using small, I wasn't getting nice fluid, so I increased this, and with flow group tension value I got a nice thin stream of the fluid. Okay, and in flow meter we can also specify volume. So if I specify 10 volume value, and then it will emit particles until 10 volume value is reached. So it will stop emitting after some frame, as you can see with 5 value. And if I go to 8, you will notice this, how it gives nice little drops at the end. But yeah, I mean, you can figure out the volume of the glass, and how much it will require to fill up this glass and give desired volume value here. Then you will not require to use time interval. So let's keep the volume to 0. And of course I have fluid with beer and foam as the subgroup, and both has the same gravity value, force value on negative z direction. And if I turn on this flow group now, we can see that color is changed for this fluid, and I'm getting nice stream here. So I will just hide cameras and help us here. So we can see that it starts to fill up the glass, and on the frame 60 we already filled up a little bit of, it's filling up very fast. So at the end of the frame we will have entire glass filled up. So main thing is here is mass and density. So this mass and density values are kind of related. So by default mass density is 1, you need to assign mass for the flow emitter because it doesn't have mass. But if you use the position bond, it has a default value of 1 for the mass. And in previously I was saying to use zero point 0.2 for the mass value, and it wasn't effective. I mean it's like, for mass 1 value you need to use density of 10 to get a nice water like stream. If I keep the tension value 0, you can see the stream here. But for the same mass value 1, 10 is desired value for the density. If I lower the density to 0.5, of course I need to decrease radius as well, and I can try 0.2 for the radius, and you can already see that it's breaking up into very tiny drops. So density value 1 is desired if you are filling up, already have particles filled up in the container, like water container, water tank. Then one density value works better, like reversing, because with lower density compared to mass, simulation goes very fast, and it's almost real time. I mean, it's very fast. I mean, you will have in few seconds the entire glass filled up, but you do not get this nice stream here. So I will use 10 for the density, and of course smoothing radius, which is required. For example, if I use mass value of 2 here, 0.2, then 10 density value is very high. You get very oil type liquid here. So of course I need to decrease density to 0.2, then 0.2, and of course I need to decrease radius as well. So mass value is 0.2, and we need to use less density for that as well. Sorry, it should be 2. Okay, so from 10 to 2, and if I use mass value 10, then I need to use density to something like probably 100, I guess. Yeah, you will see. So we are getting same result with different density and mass value. So generally rule of thumb is you keep the mass value is 1, and just change the density value as needed for the scene, and the smoothing radius. Okay, so yeah, this works really well now. And viscosity I'm using 0.1 by default. These spacer pools and pool, it works, but spacing has no effect. I generally don't use it either. And trick here I'm using is force compensation. Before I wasn't using it, but this is the main thing in this flow solver that makes it easy to fill up all the glasses or any volume. If you need to fill up, you need to keep the value to 4 or 3, and I figured if I use more than 4.4 value, it doesn't make any sense, because I don't get much effect with more value. It will just go very up, but it will have no effect. Okay, so yeah, 4 is good. And of course I'm using damping value 40. So if I set this both value is 0, which is by default, you will see the difference now. Okay, so yeah, we are not getting nice energy pressure in fluid, and we are at frame 60, and glass is not filled up there. and it's going very slow. I mean, this filling up will take like 1,000 frame or more if I go at this rate here. So if I increase force compensation to, let's try with 1, we will see the difference. Okay, so now there are more splashes, and it's better than before, but still not enough pressure or energy. And I'm also using decompress 150 here. If I go to 400, I will see some drops here coming out from this stream, like this here. And I'm also using Flowsolver volume link turned on and subsample to 2. If I reduce subsample, decompress value is very extreme and it's not good. So you must use 1 subsample for Flowsolver or 2, and master dynamics I'm using per half frame. Okay, so 1 subsample works really good, and this option must be turned on, volume link, to keep the energy of the fluid. Otherwise it doesn't keep the energy or linking between connected particles, and you don't preserve the energy volume of the fluid or pressure in the fluid if you don't keep the volume link turned on. So you can see how irregular here, and if I turn on, it becomes really nice. So let's change the subsample to 2. Okay, and yeah, so in flow group, if I increase force compensation to 3, and yeah, let's change decompress to 150 back again, you will see that now I'm getting nice stacking here, and it starts to fill up the glass, but I'm getting all this splashing here, like if we are filling up the juice in the glass, orange juice or milk, you get this nice splash here. And if I increase the stringiness, string viscosity 2.1, I will get some nice string as well here. But we can see that it's changing from blue to pink and pink to blue, so it's very violent and splashing behavior of the fluid, and energy is it's preserved here, but it's very violent and splashing going on. So I need to use a little bit damping here to keep the surface stable here. So that's also the main trick. So let me show this force compensation without volume link, and if I play now, you will see that it's not good. I mean, it goes up and it goes down again, and it doesn't keep nice pressure. I mean, we can see that here fluid is keep going up and up in the glass, and it's not good either. I mean, it's not behaving very good. So this option is must turned on for the Flowsolver in thinking particles. So let's we have found force compensation 3 value works better, and if I use 4, it will work as well. Okay, so now lots of splashing is going on, so we can try to increase damping value. You can also decrease a little bit acceleration here, but then if I go and decrease acceleration to like 10, I will have some flat here in the liquid, but let's keep it 1000. So we changed damping to 10 value, and we can see that now this fluid is more stable here, and it doesn't go very up in the glass. And of course we have volume link turned on, so particle keeps the pressure and retains all the energy. If I turn off volume link, we will see it doesn't keep the pressure, it keeps going up and up, it loses all the energy. I mean, it's not very uniform distribution of energy. So let's try something like 40 for damping value. That was our final value. And yeah, now it's very stable. You can use 20, something like that. So now we need foam over this fluid, and we can see the particles count 16,000, 17,000, and it's still going very fast. I mean, without foam, if I'm doing any juice simulation, it will be very fast and the glass will be filled up in like 10 or 15 minutes. Okay, so yeah, a little bit of friction I'm using as well, 0.1. Okay, so let's turn on foam, and it works on density change. So if I play now, you can see that foam is already generating and it's staying above this fluid. And if I zoom in, that was the idea of this scene. We can see that foam particles, it goes up as well. But if I use very strong damping, then these bubbles will be stuck here in the fluid, that we do not want. Okay, so yeah, here one more thing, that I am using in mesh condition to kill off the foam that is happening at the emission here. So if I disable this now and play again, you will see that foam is emitting from here as well. So by default density, by default value is like this 2, and rates per second I will set it to 10. Okay, so it will create 10 particles per second per fluid particle, and maximum count is foam particles maximum count, that is 150,000. And lifespan, I have given it like entire simulation time, so it's like 230. And by default viscosity to foam is 0.1 and viscosity to fluid is 1. Decompress is I think 1, density is 1, and mass factor is 0.01. So with default value, you will see it's not very good. Okay, so let me just decrease this flow emitter raster, so we have less particles and fast simulation with foam. Okay, and of course I need to increase smoothing radius then. Okay, let's keep it 0.22 and 0.5 here. Okay, so we can see that foam is emitting from here, that I needed to control. So yeah, I need to increase density change, something like 4, 5, 6, 7, let's try 15. Okay, and of course I kept this on to kill the particles outside this. And yeah, by default you are seeing foam is going above this surface here. That is because to get the foam above fluid, you need to have less density compared to main fluid density 10.5. so I will use 9. Okay, so with 9 I have foam particles inside the fluid, which is not good. Okay, so for that I need a little bit heavy mass for the foam. Okay, so now you can see it starts to appear here. But one more thing, that to get the foam particles above fluid, as we increase viscosity to fluid, foam starts to get more deep inside the fluid rather than coming above the fluid. That is because we don't have any buoyancy here for the foam. So I will use less for the viscosity fluid, and you will see foam appears on top here. Yeah, and viscosity to foam is foam viscosity, like this fluid viscosity. So I need very BL like foam and less single particles, so I will use a little bit viscosity to foam. Decompress, I will not use this here because I do not want so much gap between bubbles. Okay, and yeah, ISO value, if I use less than 3, there will be less particles on the head of the beer foam, so I will keep it 3 by default. And density change, yeah, we can use 8. It will create more particles. Yeah, probably I'm using less particle here. And inside flow groove, yeah, let's try 5 for the tension value. Yeah, now we have nice stream. Yeah, so to avoid these foam particles here, I will just turn on this condition, so foam particles which are outside this box will be killed off. Okay, so we still have this little bit here drops, so let's try 15 for the density change. And yeah, I can increase rate per second to more, so we will have more particles on the top of the beer head. But we can see that this foam that's spawning from the fluid starts to go above the fluid surface here. So as soon as particle spawn, it tries to goes up. So if I increase rate per second, we will see more the difference. Yeah, now we have more particles, and it's not just on the side, but it's on the top of the fluid surface as well. I mean, it's not just on the corner of the glass. So as it goes on further, we will have more and more foam particles on the top of the fluid surface here. So this took like I guess 30 minutes to simulate previously. So now we have this foam head is building up here. So let me show this. If I use no force compensation, like 1 value, then I will not have foam spawning up above the fluid surface. As you can see here, it remains on the bottom of the glass. So main trick is to use this force compensation, like 3 value, and little bit of damping to control the splashing. So if I don't use damping, then we have nice foam rolling up here like a wave. So let's try 40, and if I turn off volume link, then it's again bad. I mean, this stream looks bad, and there isn't nice distribution of energy. I mean, it's very violent, and it keeps going up and up in the glass, so this doesn't work well. So with this option volume link turned on, and with force compensation value to 3 or 4 and little bit of damping, we can easily fill up the glass water tank container as well, and using initial state to save the particles. So this usually works. So I hope this is useful to create nice fluid simulations using Flowsolver into thinking particles, and it's really working great now. Thank you.